In this video, we're going to talk about alkanes, alkenes, and alkynes and some basic naming of these three types of compounds. First thing we're going to do is start with organic prefixes. Organic prefixes are a little bit different than what we've previously used for our molecular compounds. We use these prefixes to denote how many carbons are in a carbon chain. So when we have one carbon in our chain, our prefix is meth, and then there'll be some sort of suffix. If our chain is 2 carbons, eth, 3 carbons, prop, 4 carbons is bute, 5 carbons is pent. So from here on out, they kind of get the same as our molecular compounds. 6 carbons is hex, 7 carbons is hept, 8 carbons is oct, 9 carbons is none, and 10 carbons is dec. And that's as high as you'll need to know for this course. And these prefixes will apply to alkanes, alkenes, and alkynes. We're first going to talk about alkanes. So alkanes are hydrocarbons that only have single bonds between carbon atoms. Alkanes have a general formula. That means a formula that will allow us to predict the chemical formula for any alkane of CnH2n plus 2. What that means is that for every carbon atom, we will have 2 times that amount plus 2 hydrogens. So CH4, C2H6, C3H8, C100, H202. So all of the formulas for alkanes will follow this general pattern. We can draw and name all of our alkanes. So we'll start with our 1 carbon alkane. This is methane. So the suffix here, ane, tells us that it's an alkane. So methane has the formula CH4. Next up is ethane. Again, same suffix, C2H6. And we can draw this as a line diagram like this. Propane will be C3H8, and it's going to have this as its line diagram where there are carbons every time the line changes. So those are the 3 carbons. Butane, C4H10. Pentane, C5H12. Hexane, C6H14. And that keeps going, and you have to know up to decane. Next up, we're going to talk about alkenes. Alkenes contain at least 1 double bond between carbon atoms. We draw a double bond as 2 lines between adjacent carbon atoms. The general formula for an alkene is CnH2n. And so for every 1 carbon, we have twice as many hydrogens. And you'll notice compared to an alkane, it's 2 hydrogens less than the alkane. We can draw and name alkenes. Our first alkene is going to be ethene. The reason it's not methene is you can't have a double bond between 1 carbon. You'll notice that the suffix has changed to ene. So ethene has the formula C2H4, and the line diagram just shows the double bond where there are carbons here and here. Next up, we have propene, C3H6, and propene is going to look like this. After propene, we have to specify where the double bond is. And we'll talk more about this in our isomer video. So butane would look like this. But1ene looks like that. So that tells me that the double bond is between the first and second carbons in my chain. I could also draw but2ene, same chemical formula. However, my double bond would be between the second and the third carbons in my chain. As you increase the length of the carbon chain, you increase the possible places that double bond could go. And so it's not quite as simple as drawing an alkane. However, you're always going to be indicating where in the chain the double bond is. Lastly, we're going to talk about alkynes. Alkynes contain at least one triple carbon-carbon bond. And so we draw that as 3 horizontal lines between our carbons. The general formula for an alkyne is CnH2n minus 2. And so for every 1 carbon we have, we'll have twice as many hydrogens minus 2. And if you compare this to an alkene, this is 2 fewer hydrogens than an alkene, and it is 4 fewer hydrogens than an alkane. So every time you add that multiple bond, you take away 2 hydrogens. When naming and drawing alkynes, the same general rule as alkenes will apply. So our first alkyne is ethyne, because we can't have a triple bond between just one carbon atom, and we've changed our suffix here to YNE. So ethyne will have the formula C2H2, and will look like 3 bonds, where our carbon atoms are located here and here. Next up would be propyne, C3H4, and propyne, we have our triple bond, and then we have our other carbon. Now in this, we have a carbon atom here, here, and here. The reason I've drawn propyne this way is because when there is a triple bond involved, the shape around the carbon atom must be linear because there's only 2 electron domains around that carbon atom. Same as with an alkene, as soon as we move into 4 carbon chain or longer, butane, we can start to move that triple bond around within the chain. So butane has 2 possibilities. So it's C4H6. However, we could draw it as double bond, triple bond on the end. So that would be but1-ine, or triple bond in the middle, and that would be but2-ine. And I'm just going to highlight here where our carbons are. So we have 1 carbon, 2 carbons, 3, 4, 1, 2, 3, 4. So with a linear shape around that triple bond. And the last thing we're going to cover is saturated versus unsaturated compounds. A saturated hydrocarbon will only contain carbon-carbon single bonds. That's the maximum number of hydrogens present, so the compound is saturated with hydrogen. So saturated hydrocarbons are alkanes or alkane derivatives. An unsaturated hydrocarbon is going to have at least 1 carbon-carbon double or 1 carbon-carbon triple bond. It could have more than one, but it has to have at least one of those features. And so an unsaturated hydrocarbon is going to be an alkene or an alkyne and their derivatives.